Good day. Welcome to another series of Chemistry Just Got Easier with DR Tutors. In this class, we are going to be talking about writing and balancing chemical equations. Chemical equations are represented in terms of symbols and formula of the elements and compounds involved. As we have known that in chemistry we have elements, and when you have combination of two or more elements, you have compounds. And we have also learned in chemistry that elements are represented by symbols. For example, you can have hydrogen represented with H, helium represented with He rather, and lithium represented with Li, and so on. And then formula of compounds. For example, an example of a compound is water. So you can have water is represented by H2O. So when we say elements are represented by symbols, what I've just written are symbols of elements and formula of the elements. Chemical equations are represented by symbols and formula of the elements and compounds involved. Now, in a chemical equation, the reactants are always written on the left-hand side while the products are written on the right-hand side. For instance here, if A and B are reactants and C and D are products. Now, A and B, as you can see, are written on the left-hand side, while C and D are written on the right-hand side. So, we are going to take an example of an equation. So, let's take an example of the reaction between hydrogen gas and oxygen gas to form water molecule. So now you can see hydrogen and oxygen are written on the left-hand side. They are the reactants. While water, which is the product of the combination between hydrogen and oxygen, is written on the right-hand side. So this is the product. And one more thing that you can get from a chemical reaction is that it tells you the state of the reactant and the product. For example, here I have gas. G represents gas. You can see I have their state here. Gas, gas, gas. If I have SSS, it means solid. If I have LL, it means liquid. And here I have 2 here in front of hydrogen and 2 here in front of water molecule. What this 2 means is 2 moles of hydrogen. The coefficients represent the number of moles. And you see here the subscript you have here means the number of atoms. So I can say I have 2 moles of hydrogen gas. But here, because I have 2 here as the coefficient of hydrogen, the total number of hydrogen atoms there becomes 2 times 2, which is 4. So 4 atoms of what? Hydrogen. Here, there is no coefficient in front of oxygen, but we take it as 1. Because let's say, for instance, you have 1x. 1x is the same thing as x. So we take the mole of oxygen here to be 1. And the subscript here indicates we have 2 atoms of oxygen. Likewise, here we have 2 moles of water molecule. And in water molecule, the total number of atoms of hydrogen becomes 2 times 2, which is 4 atoms. And for oxygen, we can say that there is no subscript written in front of oxygen. But just like I said, 1x is equals to x. So we take the subscript here as 1. So 2 times 1 is 2. So in water molecule, you have 4 atoms of hydrogen and 2 atoms of oxygen. So in a chemical reaction, it tells you the number of moles of the reactant, the number of atoms of the reactant and products. And it also tells you the states of the reactant and products. So here's an example of a chemical equation. We can see it is represented by the symbols of the elements involved and by the formula of the compound involved. So in the next class, we are going to learn how to balance chemical equations. Thank you for listening. Book the DR Tutors for your personalized online chemistry, mathematics, and biology classes at an affordable price. Follow the DR Tutors for daily chemistry and mathematics content. Follow, like, and share. Bye. See you next time.